So I believe this is about where we left off last time, right? At the statements and expressions. If we go here, let's make sure. Print values types. I'm pretty sure we finished this off. Yeah, the constants, yes. Okay. All right. Statements and expressions. All right. So programs, most of the stuff we've written have been like 1 or 2 lines of code. Well, that's what a program is, series of lines of code. All right. And each line will be doing some sort of like something. Okay, some computation. So a statement is an instruction for Python to do something. If you type a series of statements and hit run, Python does what you asked for, or at least it tries to, because maybe it won't do what you wanted or it crashes or something. So some statements result in some immediate output like this, print equals hello world, and sometimes it does work behind the scenes, like some variable equals 5. We won't see what happened, but with experience we know, oh well, the variable some value now has the value 5 associated with it after we run that line of code. An expression is a statement, but it is an expression. It is a statement that gets crunched down to a value. More precisely, I mean, really this is also an expression, it's just a very simple one. More precisely, an expression is like a combination of literal values, variables, and operators. The literals and variables are the operands, and the operators are like the plus, multiply, yada, yada, yada. Assignment operator we talked about last time. So here's an example. Some other variable equals some variable plus 1 times 2. That is a statement, but it's an expression. This can get calculated because what did we say? It was 5. 5 plus 1 is 6 times 2 is 12. So after this line runs, this should be 12, assuming some variable is in fact 5. Okay? That's an expression. You are already kind of familiar with these things probably, just not the words we use to describe them. An operator is something you're familiar with already. Operators are symbols that tell Python to perform something specific. So examples would be like arithmetic operators, plus, minus, multiplication, divide. All right? So to get started, let's do this activity. Real quick, there's actually 2 activities back to back I want you to try. The first one's a little easier. The second one requires a little bit more work, but I believe in you. So give this one a go. I'll give you a few minutes to try this, and then we'll do it together. You're doing the lab?
It was on the lab 3 instead of lecture 3.
That's way too difficult right now. All right, real quickly, let's start going through the first few questions. By the way, I often move around a lot when I'm lecturing, but my mic is low on battery, so I had to plug it in. So if I start wandering over there, tell me to go back this way, because otherwise you won't hear me on the recording. All right? So add two variables together. All right, so I don't know. Let's say A equals B, or 5, and B equals 88. I don't know. I made them up. Again, not the best variable names, but these values don't really have any meaning, so I'm being lazy with these variable names, A and B. Great. Add the variables together and save the result to some variable. Okay, C equals A plus B. And when in doubt of did it work, print C. No, that looks right. Right? Print it out. Does it look right? Looks right to me. Seems like things work just fine. Multiply two variables together and save the result to some other variable. All right. D equals, let's just do A times B this time. And to make sure it works, print D. Yeah, that sounds good enough to me. Yeah. 88 times 10 would be 888, but it's only 5, so 440. That sounds good to me. Cool. Cool. Divide results of step 2 by the result of step 1. All right. I don't really say anything to do with it, but for fun, let's do E equals 2 by 1. So D divided by C and print E. That sounds believable. Great. Yeah. And then add a third variable to the result of step 3. I'm lazy. Let's just do B again. Looks pretty good. Now, if this was like an assignment and I said, oh, okay, do all this and tell me the final answer, and you submitted something like this, you wouldn't be wrong, but I only want the final, don't give me this. In fact, for a lot of the assignments and stuff I ask you to do, there are tests built in. So similar to Caddis, where it says your output should look like this. If your output doesn't look like that and it looks different because you thought you were being helpful, don't do that. Just do what I ask you, otherwise your tests might fail. Okay? Okay. Cool. Any questions about that? I saw you were standing up. Did that answer any of your questions? Perfect. All right. Any questions or anything? Everyone's happy? Nothing? Yes.
How would you want us to write our answers if you don't want us to like write the whole?
I would say, like, if I said, like, okay, do all of that and give me the final answer, presumably I would mean, like, okay, give me F. I would want, like, this. There. Just get rid of the extra prints. Don't tell me the other things, right? Because when your output differs from what's expected, that can mess things up. And then you'll make the TA mad, and remember, markers are mean, so don't make them angry, because then they get even more mean. Okay? All right. Other questions? That was a good one. Anything else? All right, now the next one. Raise your hand if you finish this one. Raise your hand if you'll be finished this one if you had like 1 more minute. Okay, I'll take the minute, take the minute, take the minute. It looks like you were trying to plug in. There's a plug here. You can plug into it. Or you can hear it. And you should. All right. So, I'm going to be honest with you. With this question, convert temperature from Celsius to Fahrenheit. Look, I don't remember the formula. I never do. I really don't. So if you're thinking like, I don't know the formula, how can I do that? I got good news for you. Neither do I. You want to know what I do? I Google it. And I type how to convert Celsius to Fahrenheit. And it's like, okay, it's 9/5 plus 32. That's what it is. Okay, 9/5 plus 32. Okay, now I can do it. I'm not joking. I definitely never remember that. I know the 32's there. I can never remember this part. So let's just do that then. Okay, let's just go down here. So let's say I'm going to do this with variables just for fun. So let's say C equals, let's say it's 22 degrees, right? So F equals, here, maybe we should do lower cases. Again, arguably bad variable names, but I'm being lazy here. F equals, so it's C times, let's do 9/5 plus 32. Now, Python has an order of operations that you're used to, right? So I really didn't need the parentheses here, but because I'm paranoid and I also like my code to be as clear as possible, I just added it because I think it just makes it even more clear. And you know what? I like to kind of like do this. Yeah. Although it's funny, I don't like to do that. Which is kind of funny. I like spaces between my operators, except not division. It just doesn't look right to me. I don't know what to tell you. It's my thoughts. But there we go. Cool. And then print C. Well, 22. Let's print F. I'm going to guess that's right. Right? In fact, actually, let's test this. Because I do know 0 degrees is 32. That's right. And I know, what is it? Negative 40 should be the same. Yeah. Cool. All right. So if those 2 points work, chances are this is probably right. And so what did I just do there? Well, I tested it. I tested to make sure this line of code really did what it's supposed to do. And I used 2 points that I know. And if this function's right for those 2 numbers, it's probably right in general, right? It's always important to test your code. Don't just write it and be like, done. Remember, we're lucky. If you're writing code and you wonder, is my code correct? Run it. Did it do what it was supposed to? Yeah? You're probably right. At least you're probably closer to right than wrong. So there we go. Any questions about this one? Now, I mentioned this last time. There's a video here describing it, but this was using Python 2, okay? And in Python 2, if you watch that video and you see this and it's not working, it's because in Python 2 it's doing that integer division thing. And we're going to get just not correct answers. And so 0 is 32. I guess that's fine, right? Because I guess that would be 0. But the 9/5 is wrong. But in Python 3, it works just fine like that. So just be warned if you watch the video and you're like, it's different. How come you had to do? It's just a difference between Python and 2 and 3. That's all. All right. Now, operators on other types. So there are operators for values other than just numbers, and we saw this already, right? We will see many of these examples moving forward. A lot of programming is applying operators and functions and whatnot to values and doing a lot of number crunching. Now, we'll skip this activity because we already did it. Experiment with operators on strings instead of just integers. We saw this. You can add strings together, but you can't add a string to an integer. But you can multiply a string, right? These are all things that you'll just learn eventually just by doing, right? It's not trivia. I expect you to memorize. If you're the type of person that can memorize stuff, more power to you. I can't. I only learn this stuff by doing and just kind of like letting it sink in. All right, large series of statements. Often, when we're writing software, like the software that you use isn't like 5 lines of code. There's a lot of lines of code. Now, we are using Python, and Python is a scripting language, okay? And what does that really mean? For us, it doesn't really matter. It's a programming language. It's fine. But when we are writing multiple lines of code, we can write code that has as many lines of code as I want. Now, I could be writing code in like Notepad, right? I could write Python code here. No, let's just do another one. Nope. No. Print. Hello world, right? Well, this is Python code. This is. And I could run this on my computer just fine. But we're not doing it this way. We're using Colab, okay? Because Colab is a little nicer to work with when you're new at programming. So all of these lines of code, like this would be like a script, okay? And in fact, you can file, download this py file. .py means it's a Python file. By the way, for those of you that don't know this, the file extension really doesn't mean much, okay? The file extension is like the .py. That's like a hint to you and the computer, because the computer would be like, oh, files with this extension I should open up with this program, like Microsoft Word. It's like DOC or DOCX, right? Oh, I opened that with Microsoft Word. But you can open up whatever file with whatever you want, really. So a .py file, it's just a text file. But we say .py, and that means like, oh, it's a Python file. By the way, you will see stuff like this on the assignments, and you'll also see mention of an IPYNB. Right here, when I want you to submit the Python files, the .py, not the IPYNB. IPython, that means IPython notebook. It's a whole thing. But that's actually like, would be loaded up into Colab. But the way we're marking your stuff, we're not using Colab, we're using like on a computer and running the test. So it's just easier that way. If you submit the IPython notebooks, that's going to make the marker very angry. So yeah, again, don't do that. You want these ones. But yeah, I can download that, and if I go here, let's go here, and then open with, we can do Notepad, and there, it's just, there you go. It's got this stuff up here. This is just some like comments, but you can see it's the same code, right? So I can download the code to my computer, which is pretty cool. If I save this, this is a script, all right? Now, what's really cool, though, another really big benefit of Colab is everything is always saved and backed up on your Google Drive, okay? If you made a Google account strictly, did anyone make a Google account strictly for this course? They didn't, okay, great. So you Google Drive. Here's the good news. You can never accidentally delete your it's saved on Google Drive. It's never going anywhere. You don't need to worry. Your computer crashed, don't worry, it was saved in the cloud. You don't have to lose anything. It's all there. All right, so yeah, it's saved and it's saved in like Google Colab. And when we run this script, Python runs each line one at a time in a very systematic way. It starts at the beginning, goes to the next one, goes to the next one, goes to the next one, goes to the next one. It can jump around a little bit, but in a very predictable way that we're going to learn all about as we go. And typically, you can write a program in any text editor you want. Colab, for example, there's Notepad++. I like that one myself. It's very simple, very lightweight. We've got Sublime. There's PyCharm. That's a beefy IDE. VS Code. That's a lightweight IDE. There's a lot of different places we can write code. We're using Colab because it's simple. All right. And we'll skip this activity because it's taken directly from one of the exercises in one of the labs. You did this already, that like all work and no play one. So we did that one already. All right? But there is a video here if you want to work through that one on your own. By all means, I encourage you. All right. And that's a quick little thing on statements and expressions. A lot of times people will use these words interchangeably. Really, a statement is a catch-all. Expression is a certain type of statement that does some like number crunching. But ultimately, they're all statements, okay? And you put a bunch of them together, you have a script. You've got a program. Cool? Any questions? I'll give you a second to think about your questions. Ask them, ask them, ask them when you got them. Okie dokie. All right. input and changing types. We already did this in the lab, but let's go over it again. We saw how we can get information out of the program to be displayed. That was print. But there's also a very simple way that you've already seen to get information into the program. Now, in general, we don't actually use this very much. But like we use it in lab for caddis and in a couple of cases. But in general, we're not using this enough. If you start using inputs on your assignment 1, you're doing it wrong. You're not following the instructions. You're trying to impress somebody. Don't impress me or the TA. You're going to make them mad. So input is a great way to get information into your program. But here, let's just do this. Here, I'm just going to delete these. Delete. And let's just, there. All right? We already saw something like this, right? The input is a function. You can put a string in here, and that's what gets displayed. And the program is actually like halted here, and it's waiting. It's waiting for the user to add the input. I showed you on caddis, though. Do you ever want to put something in here? If you're using caddis? Everyone on the count of 3, yell the answer. 1, 2, 3.
No.
Good. Correct. No. Absolutely not, because caddis will be like, no, the answer's 5, not give me the input value 5. Clearly you're wrong, right? Just do what it says. So 5. Great. Now, when you see this, though, like, well, did it work? Okay, well, let's test. Here's what we're going to do. We're going to do it again, and then immediately print the output, or immediately print what was just inputted out. It's a silly program, but it's a good way to see how is it working. Give me a value 5. It shows me 5. But based on what we talked about in lab, what is the type of this? Everyone answer on the count of 3. 1, 2, 3. Literal. Literal is a good answer. Well, that is a literal, but it was stored in the variable, so Okay, let's try again. It's type. 1, 2, 3. Come on, say it with more vigor. 1, 2. Who said integer? You fool. It's always a string. I know it looks like an integer. By the way, I'm doing this because this is always the thing. So I'm picking on you because you did what I wanted you to do. Everyone always, it's an integer. It's not. It's a string. Whenever you read input, it's always, always, always a string. And why is this important? Let me show you. I've already showed you, but I'm going to show you again. And then print plus my, yep, cool. And you're like, okay, so I'm just adding these two numbers together, 1 and 1, which is, of course, 11, right? Obviously, that's not right. I mean, it is correct. The computer did exactly what it was told to do. But you got to know that whenever you input, it's always a string, okay? So when you've got the string 1 and the string 1, and you add them together, what does add on string do? Concatenates. So we see 11. But we all know, maybe this is what you wanted, but I'm guessing if you did this, probably you wanted the answer to be 2 in this situation. And you might think, how would it, why can't it just know, right? Well, look, it can't just magically know. And as a safe catch-all, because I could be doing this, and it's going to work just fine, right? Everything can be a string. But if that string you inputted really was meant to be an integer, here's what we can do. We could say my inputted value equals the int of my inputted value, and my other inputted value equals the int of my, there. And now if I do 1 and 1, I get 2. So it starts as a string, I convert them to integers, and then I do it there. Yes? Absolutely. Thank you for asking. Great question. He just asked, okay, so you read it in, and then you converted it. But could you just do that in one shot? Yes. What does that mean? Let me show you. I could just say this. Whoop. Right? So, the first line of code will read the input. The input's in here, and then it immediately gets turned to an int and then assigned to this. Because remember, the full right-hand side of the expression always gets calculated first. However, I don't do this. And I would encourage you not to do this. There's nothing wrong with this. It's absolutely correct. I totally would do this sometimes for quick and dirty solutions. But if I'm writing software, I wouldn't do it this way. Does anyone want to take a guess why I wouldn't do it this way? I have no expectation that you would know. I'm just curious if anyone wants to give it a shot. That's kind of part of it, I suppose. But any other ideas? Here's why. Programmers are stupid. Okay? We can't do more than one line of thing. We can only do one thing at a time. That's why all our programs are like one thing at a time. However, we want our code to be as easy to follow as possible. Short does not mean easy to follow. In fact, often going out of your way to make your code shorter makes it more difficult to understand. More verbose code can often be quite straightforward. The reason I discourage this is this line, I like my lines of code to do one thing. I want this line of code is doing two things. It's reading the input, turning it into an integer. That's really not that bad. This is actually pretty common, but in general, I dislike it. I prefer one line of code, do one thing. And I guess I could have put this right under and then right input, but I don't know. I like it this way. Read the inputs, convert them to integers, do the addition. To me, it's easier to follow. Have each line of code do as little as possible, so it's more straightforward. If you did the int up here for caddis or for something you had to do, I wouldn't ask you to do this on an assignment, except assignment 3 where you're playing tic-tac-toe, you do input. If you're to do something like that on assignment 3, it's fine. No one's going to get mad at you, but I would say it's better to have your code as straightforward and simple and easy to mentally parse as possible. So thanks for asking, because I was about to talk about that anyways. Yeah. Another person might be wondering, okay, but what happens if I type in hello? We may have done this one already, actually, but let's see, right? Read the input, right? I could do hello, and I can do world. And when I hit enter, what does that mean? Well, okay, this is going to be hello, this will be world. Once I hit enter, this will be the string hello, this will be the string world. And then I say, take the string hello and convert it to an integer, right? So who wants to be my volunteer? Take the string hello and convert it to an integer. Exactly. No. It just goes, what? And it says, I can't convert invalid literal for int with base 10, hello. This is a fancy way of saying, I can't turn the string hello into a base 10 number. I can't make that a number. Base 10, that's just a number we're used to, right? It's saying I can't do that. And if you're like, well, why would it crash? Well, if I ask you to do that, you're not going to know how to do it unless I give you special instructions, take the sum of the characters based on their alphabet. That's nonsense, right? That's arbitrary. So this would crash, right? But presumably, if the software is being used correctly and you give it an integer, it'll be just fine. All right? In this case, you actually would want your program to crash because you want your code to be predictable. And if you say, convert this string hello to an integer, and it gives you some number, that's kind of weird, right? If the data became a problem and you can't number crunch, I would rather Python not try to get creative with a solution. I would rather it to be I can't, you're asking me to do something ridiculous. So that's a better thing, actually. You got to look at these errors like this as a positive thing. The programming language, Python, is trying to be helpful in telling you, like, you're trying to do something that doesn't make any sense. It's giving you advice. All right, yeah, okay, we just did that, cool. All right, and yeah, now have some, no, I kind of spoiled this already. We'll skip this one. Read some input into your computer, print it out. What's its type? On the count of 3, what's its type when you input it? 1, 2, 3. Very good. Is it an integer? No, not unless you make it one. There, very good. Very good, yeah. You might wonder, if I go back here, well, could you convert it, like, what about a float? Right, like 5, and what if I did 5.5? When I hit enter, here's a quick thing. Don't yell out the answer this time. Don't raise your hand. Take 5 seconds. Look at this code. Mind the fact that I changed line 4. I changed it to convert it to a float. Think, when I hit enter, what output do you expect to see? Lock in an answer in your head. I'll give you 5 seconds. I'll give you until I'm done taking a drink. All right. Does that look right to you? Yeah. Now, here's what I would think is reasonable. So first of all, you'll notice it had no problem converting line 4. Line 4 was 5. The issue was line 5. And it was saying, I can't convert 5.5 to an integer. Now, you might say, well, couldn't it just like do that truncate thing? Let me show you what I mean. No, stop. Like if I said, print the float of 5.5. Nope, print. No, int. That worked. Okay, so what's the difference here? So I said take the float 5.5. We know it's a float because it's got a decimal. It just is. It's the literal 5.5. And I said convert it to an integer. And like we talked last time, an integer, when you take a float and you want it to be an integer, it truncates any decimal. I could do 5.9999999. I hope Python doesn't try to help me here and make it 6. Oh. This is Python's lying to you. Don't trust Python. Let's go down to here. There. Okay, that's good. Python when it's I hate Python when it tries to be helpful. And that was an example, like it should not have done that. That is very not predictable. That's very bad, but whatever. Anyways, 5.999. What should have happened is what happened here is we truncate off the 9s. It gets rounded down. It always rounds down. That's the typical behavior. Python was being weird and helpful. So how come we could do this, but up here, it didn't work? Can anyone tell me why? First of all, you'll notice this worked just fine. But why did it not work here? Didn't I do the exact same thing? Does anyone notice the nuance difference?
The 5.5 for the input one is a string, whereas the one below is the...
Exactly. I was asking, and this is an example of, oh, I thought that would have worked. That's entirely reasonable. But here's why this worked, is I took the float 5.999 and converted it to an integer. Python's happy. It can do that. Here, I was asking it to take the string 5.5 and convert it to an integer. And it was unhappy with that. You might think, couldn't it have figured that out? That's a good point. Turns out it won't. If you really wanted something like that to happen, we could do this. Here I am doing multiple things on one line of code again. But if we do like 5 and 5.5, let's go again. Pay attention to this code. When I hit enter, lock in an answer in your head. What do you expect to see? 10. Right? Why? Well, 5 got converted to the float 5. In fact, here, for fun, let's do print my inputted value, and then here, print my other inputted value. 5 and 5.5. Great. Notice that the 5 actually turned into 5.0. Well, because that's the float. And then this one, the 5.5, got converted to a float 5.5 and then immediately to an integer, which we know it's happy to do. And there we go. Cool. Now, why is the answer a float? Because this one's a float, and if one of them's a float, it'll just turn the result into a float. If this was an integer and this was an integer, the answer would be an integer. But as long as there's one float, it's going to just calculate and give you a float in the end. If at this stage you're like, I'm gonna have to memorize, no, you're thinking about programming wrong. You want to know what you do? Is you hit run and it goes, I can't convert it. And then you go like, oh, weird. I guess I could convert it to a float first and then an integer, right? Like no programmer like memorizes all of this crap. Eventually, this level of like trivia, programmers just know because of experience. But if you're picking up Python for the first time, you could be the world's best software engineer, and but you've never used Python, and you pick up Python for the first time, you would never know that it would have acted like that. It's a matter of just trying it and going, oh, that's okay, I guess we got to do it a different way. Why? Because someone, somewhere said so. A Dutch guy said so. It's just the way it is. Yeah. It was a Dutch guy named Guido. His picture is, where's Guido? His picture's on the wall somewhere. Did we take it down? Yeah, there he is. Third on the top on the left. He looks really happy. He's kind of a weird guy, but hopefully he doesn't see this video. I'm not too worried. I'm really not too worried. I think he'd probably agree. But he's an interesting character. He's the guy that like invented Python. So thank him for everything. Thanks, Guido. Yes, everyone say thank you, Guido. There you go. Yeah. Yeah, thanks, Guido. Yeah. All right. All right, so the type of the inputs, like I said, it's always a string, so you got to be careful. If you want it to be an integer, convert it. You wouldn't be the first person to forget to convert. It happens all the time. Changing types, that's easy. We just did, like, I just showed you how to do that. So here, let's do this activity. Now we can actually get to something fun. All right? Write a program to do all of that. There you go. Have fun with that one. You got a question? Just stretch it. No worries. Most of the time people do, right? But whatever. And the argument, so someone just said like, really not converted on that line? Look, it's entirely reasonable to, although yeah, it's good to have one line of code do one thing. When that line of code, like yes, that line of code is doing two things. It's reading the input and converting it. You could think as like a functional unit, it really is only doing one thing. It's reading the input as an integer, right? So you can make that argument, and it's entirely fine to do that. I just use it as an example to like, it's kind of nice to have one line of code do one thing explicitly, but whatever. Does anyone know why? This is an interesting little piece of trivia. Does anyone know why, like, the short form for pounds is LBS? No one? I don't even know. Images. It's because like Libra is like a scale, right? And so it came from like astronomy, which is pretty cool, right? I think that's kind of neat. I love when like there's like an interesting like cultural story to something like that, right? So libs, pounds, why? That doesn't make any sense, right? Well, that's why, yeah. All right, libs.
Keeps auto-completing any of my variables W, and it keeps auto-completing to while I hit enter.
Oh, okay, that's all.
All right, convert it to a float. I just did it in one line. I did exactly what I told you not to do. Calculate the mass of an individual in kilograms based on the inputted weight. So kg equals, and if you're like, how do I convert 1 pound equals that? All you have to do is just multiply the inputted by that number, and you're going to be fine. So equals LBS times, what was it? 0.453592. 0.453, what was it? 592. And then print.
Wait, go back to the cell or go back to the code?
Ugh. What's going on here? KG. And I forgot to close the parentheses. That's why. So, I don't know, let's say I weigh 150 pounds, 68 kilograms. Does that sound right? I'm not good with kilograms. I believe it. Yeah? Good enough? Cool. Great. Awesome. Isn't it funny how, like, in Canada, we pride ourselves on using the metric system, except we hardly ever do? Like, what do you set your oven to? 350 Celsius? Fahrenheit. What about pool? What's a good temperature to go swimming in a pool?
80 degrees.
80 degrees Celsius? I don't know about that. Fahrenheit. Gee. How much do you weigh? 170 kilograms? Oh, gee. Wow. You're a big guy. I don't know. Right? Like, how tall are you? Foot. What are you talking about? Are we We're lying to ourselves as Canadians. We love to pretend, oh, we love kilometers. Yeah, but that's about it, right? Anyways. Cool. Any questions about that one? Yeah? Hey, here's another funny thing. You see these symbols here. What do we call these? Braces? No, braces are these ones, the squiggles. These are braces. Everyone calls these brackets. That's not right. These are called parentheses, actually, by the way. These are brackets. Sometimes people call them square brackets, but they are brackets. Does anyone know what the origin of the word bracket is? Probably something very close. It's actually from the Gauls, who lived in the area of France well before France was France. And it came from like a word that meant, like, it wasn't bracket, but it was a similar word that meant pants. But like pants weren't big in Rome, so the word stuck around after the Romans invaded, so the word meant pants. And then, for whatever reason, does anyone know what a codpiece is? It's a very weird fashion thing that was really big in the Middle Ages. It's basically this thing that covers you here, okay? And King Henry VIII had a really big one. And I don't know, and they called it like braquette or something. And now you might be saying, how on earth did it get to there? Well, does anyone know the story of Pocahontas? Well, turns out, so a little while after, pillars, they used brackets. Like if you're building something and you're using a bracket, the shape on the bracket, on the bottom of the pillar, they started calling them like brackets as like this cutesy thing in reference to King Henry VIII, even though it had nothing to do. But that word stuck around. And then, you know the story of Pocahontas, and then like what, Captain John Smith? Well, Captain John Smith, after he left North America, he wrote like a nautical dictionary, and he like misspelled it as like bracket, and then this word came. Anyways, it's a weird connection, but now we've got a bunch of brackets on our keyboard, and there we go. So that's a funny little story for you. How about that? Words are wild, aren't they? All right. Anyways, does anyone have any final questions, not about brackets, but about what we just did here in terms of this chunk of code? It's more of the same. All we did was read the input. I immediately converted it to a float, like I say, don't do. I did the calculation by taking, well, for every 1 pound, there's that many kilograms, so just multiply it, print out the kilograms. There we go. Cool. Any last questions? Everyone's happy? All right, I'll see half of you tomorrow and everyone on Friday. See you.